Hello, everybody. It is January 13th, 2023, and this is the OLM Dev Working Group, and we're going to discuss the next generation of the CatalogSource API. With that, I'm going to hand it off to Anik.
Yeah, thank you, Alex. So while we are designing and discussing OLM V1, we've been looking at the V0 CatalogSource architecture, and we've been rethinking about how we can re-implement CatalogSource for V1. And I'm going to start off with first a brief introduction of the architecture of V0 and talk about some of the problems that we faced in this V0 architecture. These are sort of like the motivation for why we are thinking about re-implementing the CatalogSource architecture. And then from there, we'll go into some of the solutions that we've been discussing in the HackMD. And I guess we can, I'm sorry, I'm trying to find where my cursor is right now. Yeah, okay, I see it. Yeah, I guess we can link the HackMD in the YouTube comment. But I've got this neat Miro board that has all the architectures and all the problems kind of laid down as bullet points. So yeah, we'll look at the solutions that we've been discussing and then start off a discussion on the pros and cons of the solution, see if we can get a green signal, and if we feel there's a lazy consensus on going ahead with one of the designs. Okay, with that out of the way, so today, when you create a catalog source, so we've got a catalog is basically an operator catalog, right? Like you've got once an operator author builds an operator, and he or she wants to ship it with one of the many catalogs that are available out there, they kind of package it inside a index image, and that is a container image hosted in an image remote registry. And our job then is to get that catalog image and make the content of that image available on cluster. And to do that, we've got something called the CatalogSource CR. So when you create a CatalogSource CR that specifies that container image, it creates, for each catalog source that you create, it creates a pod that is basically a pod that has a gRPC server exposed, that has a list of API endpoints. For example, get bundle for channel, list bundle. And these endpoints can be reached out to get the content of the catalog metadata. That is basically, for example, we had the SQLite database. That SQLite database was served with the help of a tool called OPM. So OPM serve SQLite database, and that would expose this API surface, get bundle for channel, for that particular database in that port. And then we package that in a container image and expose that in a pod. But over time, we've realized that wasn't enough. We couldn't. So if our clients started having specialized requests, like I want to see the packages that are available in this, which is pretty standard. But then I want to see the description of the package, and I want to see the icon of each package. And then I think over time it became untenable to ask the clients to connect to the list bundle, to every registry pod, and query these API endpoints every time they needed request. So that gave birth to a custom, an aggregated API service that we call the package server, which also basically reaches out to all of these registry pods. And then all it does is it calls the list bundle, but then it processes the response in those list bundle, and then creates package manifest, a CR called package manifest for each of those packages. And I've got an example of the package manifest over here. So as you can see, once a catalog source is created, for each of the operator packages that are out there, for example, this is an example of an etcd package that's available in the community operator or operator hub IO catalog that's shipped with OLM right now. And that basically lays out all of the information in its status field. So, the current CSV for each channel, display name, bunch of the icon for the package, the CRDs for the package. So we've got that resource. And then the other client that we have majorly reaching out to the list bundle was our dependency resolver. That is in the subscription controller. That also basically calls the list bundle whenever there was a dependency resolution needed. It reaches out to each and every pod and gets the bundles from each of those catalog sources, but it creates over time it became apparent that reaching out to all of these pods every time that it needed to resolve dependencies was more expensive. So it started creating caches for each of the catalogs that are present in the cluster. And then we eventually needed complex cache maintenance mechanism because these are in-memory caches. So we needed complicated cache maintenance. Yeah, I'm not looking at the chat. So if there's anything,
yeah, don't worry about it. It's basically just we're kind of just saying that it's fundamentally it's a nice translation layer from all the gRPC APIs to a nice kube API.
Right. Right, and that is basically the inspiration for the package server, right? Like that is more of a kube native way of knowing what packages are in the cluster than reaching out to the curling the pods and getting the list bundle and then processing the result yourself. That's just a lot of manual steps. That is not very kube native. Anyway, this is the very brief.
Just one takeaway. I want to say that I think this is a largely undocumented feature that everybody loves once they figure out it's there.
Right. Okay. So that is a very important point. Thank you for pointing that out, Chris, because that becomes, I think that statement will become a little bit more like we'll have to keep that in mind when we're talking about the next solutions, the next gen designs. So do bring that up, or if it sounds like we're forgetting that. Okay, so this is the very brief introduction to what the catalog source architecture looks like. But here's a laundry list of problems that we've kind of faced in maintaining this architecture. So I mean, first of all, when we are thinking about OLM V1, I think a larger problem that we faced is, or we're trying to solve is, even in terms of dependency resolution for operator dependencies, we are currently having discussions about whether things should be cluster scoped or name scoped and what are the pros and cons of all of that stuff. But I think at this point we are leading towards everything in OLM V1 will be cluster scoped. So even the catalogs that you create right now in V0, you can create when you create a catalog source, unless they are in a global namespace. And I'll come to what global namespaces are in a minute. All the packages that are available in the catalog source is only visible in that particular namespace. So if you want to install an operator in namespace foo where catalog bar is there, you can install namespace foo in namespace bar. But then if you try to search for that package from another namespace, then that is not visible to that namespace. And that is our way of solving multi-tenancy. But we've got specialized namespaces, at least in OpenShift, that is basically hard-coded in the dependency resolver to look at as global namespaces. So if you create these catalogs in these namespaces, then these packages are available or visible from every namespace in the cluster. But that is a very hard-coded one namespace in the cluster, in the entire cluster. I think upstream, that's the OLM namespace. So any catalog that you create in the OLM namespace is a global catalog, which is at odds with the OLM V1 architecture, because now you're basically saying that if you have to port over this architecture, then all you can ever do is create names, catalogs in that one particular namespace. The other problem that is obvious is the catalog operator, the OLM catalog operator. It reconciles other V0 CRs, so there's just a lot of tech debt that it's going to be pretty hard to kind of strip down and just take out the catalog source reconciliation logic, I guess. Then yeah, I talked about the package server, right? Why the package server was needed. But downstream, we needed something called the package server manager, because right. So downstream, we needed a package server manager that basically does a lot of in OpenShift, at least we've got, for example, the cluster version operator that reverts any changes to any of the shipped payload. So we needed the package server manager to have that same feature for the package server, and that kind of increased the fork between what's upstream and what's downstream, thereby increasing the maintenance burden on everything surrounding the package server. The other problem that we
So, Anik, real quick on that, the main reason that needs to exist is because in Kubernetes, aggregated API servers should be high availability such that there's no downtime when you update them. So we needed typically to have two package servers running at all times, so that if one went down and we were doing a rollout, there's one that you can talk to at any given point. So something like if we go with an aggregated API server in the future, we have to think about that aspect of it.
Okay. Okay, that's also interesting, because then there are situations when one of the package server or one of the instances of the custom API server can be down, and that won't affect the main API server, is what I'm hearing. Because if we have the logic that, okay, bring up another package server, another custom aggregated API server, that means that it's okay for us to kind of assume that it's safe for the package server to be down, and it won't. But anyways, it won't affect the main API server, but I think I'm getting ahead of myself, at least in terms of this presentation. The other problem that we've seen is CPU and memory consumption spikes in these registry pods. And that became especially a problem around the time when we were migrating from SQLite databases to FBC. In the HackMD, I list a lot of Bugzillas and Jira issues where or upstream issues where customers have seen huge memory consumption spikes for sometimes over a long period of time for these registry pods. And that became a sort of huge effort from our side to kind of get those memory consumption down. Besides the memory consumption, we've also had
So, Anik, one more thing on that one, just because I can add a little more color there. So it turns out a lot of the reason for those spikes is because we still have this gRPC API that we need to serve, and FBC just doesn't align very well with how the gRPC server APIs want to be able to query data. So essentially what was happening is at startup, we would kind of repackage, like read the entire FBC and repackage it, recache it on disk, and that all of that process to kind of reorganize it to a point where we could serve the gRPC API took a lot of memory and took some time. So essentially like a root cause of that problem is that FBC is not indexable really. And so you've got to do some post-processing on it to make it easy to serve specific answers to questions that clients might have. If you're thinking about this in terms of the gRPC API or any other API that might want to know about specific packages or specific bundles or something.
Right. I think what you're alluding to is, or at least one of those things was, I think the OLM.bundle.object that the package server needed. But yeah, specific fields like that the clients have already come.
It's not really that. It's more of like, if you're looking for a particular bundle in an FBC root directory, you have no idea where that is. You have to literally just parse every single JSON or YAML file there until you find it.
Right.
I think that's a shortcoming of our FBC design.
Yeah, I mean, the FBC is basically just a large set of JSON documents, and you have to index it to be able to serve up answers to questions that existing APIs have. Bottom line, right?
Exactly.
There's a lot of parsing and marshalling and stuff you got to deal with.
Yep.
Okay. So basically, this entire architecture is, our FBC needs to do a lot of jumping through hoops to kind of fit into this entire architecture is what I'm hearing right now, which is the main cause of this CPU and memory consumption spikes. Okay. Besides that, we've also had a glaring issue with maintaining this pods itself. So basically, we were creating and maintaining this pods ourselves instead of using any workload API. So and over time, what started happening was we basically had to re-implement whatever the workload API, a lot of the work that the workload API gives us for free, but then we had to re-implement that in the CatalogSource CR. For example, users had a request saying that, hey, you guys schedule these pods, but then I have no way of controlling where these pods, I want to add taints and tolerations for nodes for in these pods, but then I have no way of doing that. So we had to go and expose a field in the spec of the CatalogSource CR called the gRPC pod config. And that just sounds like an ever expanding field, because every feature that is available in a workload API can be included in that. And as customers come up with requests, I think that just has the potential of us turning into us basically re-implementing everything that workload APIs do. And the pod security admission issue was another one where before, when we created these pods, we didn't have to think about setting user ID and setting any of the pod security fields. But then recently in OpenShift, we've been thinking about enforcing different levels of pod security admission. And that turned into a huge effort that, again, I mentioned in the HackMD, in basically expanding the CatalogSource CR or redoing these pods to make sure that they can handle these pod security admissions. And all of that, we just get it for free if we had used it for the workload API. APIs like the deployment or stateful sets, but since we were creating and maintaining these pods ourselves, it just became.
Yeah, so I think the in a nutshell, the CatalogSource CR is almost turning into an opinionated deployment YAML, right? It's getting more and more details in there because there is no deployment, right? It's managing the pod directly, the pods.
Right. And if you look at like the Kubernetes docs, it says outright that you should not be creating pods yourself. Instead, use the deployment of the stateful set API. But when this architecture was, I think, implemented, it's been like 4 or 5 more years than these kind of standard best practices, I don't think was laid out at that point of time. So we got away with just creating and managing the pods ourselves, which at this point of time is becoming a huge burden on us. Okay.
There's another related problem here, Oleg, which is that right now in OLM V0, we expect those catalog images to have binaries that run by default when the pod starts.
Right.
So we don't really technically, like, we don't control those binaries from an OLM or from an OLM standpoint. So we don't really know what those are. We don't know what they do. And so that's part of the reason that like PSA is important, because then we can sort of lock that stuff down. But then at the same time, that wasn't a thing that OLM ever thought about in the past. The other problem with a binary running there is that it essentially introduces another external API, right? Like that means that OLM has to have a backwards compatibility guarantee about gRPC, because we've essentially said that any catalog pod that has ever existed will continue to work, mostly, right? And so that means that we have a strict API guarantee on that gRPC API, which is a little bit problematic because we also have this guarantee on our FBC or our essentially our SQLite APIs as well. So now we've got two APIs in there that sort of need to stay kind of in sync, or at least like have servers. It just gets really weird, right, when there's two APIs. So I think another piece of this problem is thinking about whether, if we still do need to serve catalog content on cluster, making it such that the catalog images are content only. And then another benefit there is the multi-arch problem, right? Like if you've got a binary that's in that catalog image also has to be multi-arch compatible so that it runs on all the different architectures that we want to support. And that's a huge pain for catalog maintainers because they also have to think about those problems as well.
Right. And it's probably worth calling out the fact that, I mean, besides the SQLite and the gRPC, we've got the package manifest, then the catalog source. So the API surface in itself, it's so huge. And that made sense when you had the underlying data store as SQLite databases, which needed all of these wrappers around for users to consume. So, nobody's going to be cracking open the database and getting any information out of there. So we needed all of these APIs surrounding the SQLite database. But with the introduction of FBC, which itself is a human readable JSON database, all of these APIs all of these wrappers surrounding the underlying store just is an overkill at this point of time, which again, before we had the discussion about why the FBC in this architecture is causing CPU and memory spikes. So that means that there is a potential to use this new format to sort of build an architecture that is lightweight and doesn't have to or can take the advantage of the fact that it's more human readable and it's more editable and it's more declarative than what SQLite databases are.
Yeah, I think the takeaway that I'd like to see is, let's not bundle any binaries in the catalog image at all. Let's just have the catalog image just be the catalog, right? And I think that's maybe where you guys are heading.
Right. Okay. Yeah. I don't know if I interrupted anybody.
One other thing that maybe is an interesting thing to highlight here, which is maybe not super relevant, but just for context, is that there's nothing really that's preventing us from doing that right now in OLM V0. Like we know
I've written that myself.
Yeah.
I've written one of those myself just for sanity. Yeah.
So we could totally do that. Essentially, like what we'd be signing up for from an OLM maintenance perspective is any catalog, any source data. So whether it's an SQLite database or an FBC that we've ever produced out of OPM needs to be supported, right? So like right now we say that like any gRPC API needs to be supported, but we'd be basically backing that up one step and saying, okay, any of the data that's currently being used to serve that API, that's what we'll support. And then when if OLM ran our own binary and unpacks this plain catalog information, whether it be a DB or an FBC, that binary would just need to be able to support all the different possibilities of what the input data is that we've.
Yeah, that would simplify the catalog producer's life immensely, I think.
Yeah.
But
Okay.
that's
Sorry.
the OPM render you're talking about, right? For example.
Kinda, yeah. I mean, it wouldn't necessarily need to go through all of those extra steps. Like we could detect like, oh, it's a DB, so let's start up the DB server, or oh, it's an FBC, so let's start up the FBC server.
Oh, I see what you mean. Okay, yeah, that is okay. I see what you mean, but then that also means that is just taking away the pain point from the catalog maintainers and putting the pain point on the OLM maintainers, because now you're basically maintaining all of the underlying data store paths that can be taken by catalog maintainers in your code base, which
Yep.
is yeah. Okay.
But I would totally argue that that's the direction we should go. Like we need to, right now we kind of still have that problem, because we still have to think about how do we build OPM such that it always serves this gRPC API that we've all agreed on. And like it's up to us to have APIs that we maintain backward compatibility for. So all I'm suggesting is that, you know, we can move that problem around and then also at the same time solve a bunch of problems for the catalog maintainers. And I think like it's anytime there's a question between are we going to help out ourselves at the detriment of our users, or are we going to help out our users at the detriment of us? We should do the latter. Like we should always help out our users.
Yes, but also, I mean, it's also worth, I think, for the purpose of this call, worth mentioning that at this point of time, the SQLite database is deprecated. SQLite database as the underlying store is deprecated. So since it's deprecated, I think the goal there is, or the hope there is, at some point we'll be removing that, and therefore all of the code base components surrounding the SQLite database.
OLM V1, we should not continue support for SQLite.
Okay. So that means we are talking about the same thing. I forget the fact that you mentioned that in V0 we can do this. And I forget that you prefaced that conversation with that. But yes.
Yeah, I just think the important, parallel there is there might be another iteration of FBC, right? And so whatever the iteration ends up being, we need to tolerate that coexistence, right?
Yes.
FBC V2 at some point, maybe, right?
Right. So that's obvious. I mean, one of the main selling point of FBC is that it's declarative and it's extensible. So at least when we are designing, when we talk about these designs, I think it tries to keep in mind the fact that FBC is extensible, and we try to get to a path where we have to do minimal changes in the component in order to accommodate FBC2 or FBC3 or any of that sort.
But regardless, like no one ever gets their APIs perfect, and APIs need to evolve. And at some point in the future, we'll need to make a breaking change such that FBC V1 is not necessarily compatible with FBC V2. And so the things that make that FBC available on cluster will need to understand the difference between V1 and V2.
Right.
Yeah, I think that's just the whole point. It's just make sure we future-proof ourselves, right?
Right.
I think it's important to call out too, though, that means if we introduce an FBC V2 or whatever breaking change, people who adopt that and start producing catalogs using that, those catalogs will not be consumable from older clusters that are running an older OLM, which is not the case today, right? Today, somebody can produce a new catalog using the latest OPM as long as the gRPC API hasn't changed, and anybody can run that catalog on an older cluster. Not saying that is a reason not to do it, but that is a benefit we have today that gets lost going forward for catalog producers.
Yes, Ben, but like essentially what we're saying, I think the comparison there is in the future, it's FBC V1 versus FBC V2. versus gRPC V1 versus gRPC V2, right? Like we haven't been able to change our gRPC API because of this problem.
Yeah, totally true. It's shifting the problem.
Yeah, I mean, the Ben, I think, brings out an important point too, that a lot of the reasons that we have this, you can build an you can build a catalog with the latest OPM, but it has to run in a very old cluster, is because of the fact that we did not have release cadence for OPM that laid out what OPM is compatible with which version of, I don't know, Kubernetes cluster or OpenShift and stuff like that. And that probably is tying into the, do we need a binary in these pods? So probably we solve a lot of these problems by just getting rid of a binary if we can, instead of putting that binary in the pods.
It really comes down to what are the external APIs that OLM on cluster signs up to support, right? Like right now today, OLM on cluster actually has no idea that FBC or SQLite exist. It's just a gRPC API.
Right. And that's probably a good segue. Thank you, Joe, to the goals that I've laid out over here. It sounds like, so in the goals, I've laid out only 2 points. And if you go into the HackMD, there's more description about that. But then just as bullet points, I think I've picked up, a cluster scoped API that lets user indicate the location of the FBC metadata in a remote location. So it's the index image field that I'm talking about. And then reduce this API surface to just leverage FBC. And it sounds like all of the conversations that we've talked about ties into these 2 goals. At least I didn't pick up any other point that needs to be added to the goal, but if there is, feel free to add, suggest that. The one thing that I wanted to call out before we move on is I'm putting this out of scope in the interest of keeping this well scoped, keeping this discussion well scoped, which is how do we so for the folks who haven't been tuned in, we've been discussing about, or we've been thinking about how can we ship and store and ship our FBC in OCI registries, so Open Container Initiative registries, but as OCI artifacts. When we started shipping bundles as index or as container images, or catalogs as container images, OCI images, OCI artifacts was not, I think there was a little bit of a pushback too, in using the container image format in storing metadata files. But it turns out there are other folks who've also had this use case. So OCI artifacts have been worked on as a result over the last few years. And it looks like the work's come further down the line, further enough that we can sort of look into taking advantage of OCI artifacts as the underlying shipping mechanism for FBC. But for the purpose of this discussion, the architectures we talk about, I think I'm trying to keep this out of scope, and we'll just assume that whatever the component on cluster pulls this images, whether it's a container image or OCI artifact, has a standard way of pulling this image and unpacking this image. And by that, I mean, it can be a Docker pull and Docker CP, or it can be a ORAS pull, and that's about it, if it's an OCI artifact. But that I'm trying to keep that out of scope. And that's where all the discussion about, okay, how do the mirroring of registries for disconnected environment and all of that conversation will come in. But again, just so that we are all on the same page, I'm trying to keep that out of scope for this discussion. So with that in mind, I've listed down some of the problems we are trying to solve so that we can, look at this as summary bullet points. One is the pods problem, and I'm bundling in all of the conversation that we've had about, the pod scheduling and memory spikes and the API guarantees, gRPC API, all of that problem is, being overloaded into this overloaded term, the pods problem. But for the sake of, keeping things short, The other problem that we're trying to solve is content availability on cluster. So yes, we have these content, the FBC available, shipped to remote registries, but we need a way to get that down to clusters and serve that content to clients on clusters so that clients don't have to reach out to the network every time they need that content. The other problem is obviously the cluster resource consumption. So the CPU spikes, and then the dependency resolver, for example, or any other client on cluster needing to cache all of these results to reduce the network consumption. And any of the other resource consumption problem that we've talked about is being bundled into this cluster resource consumption problem. And I see someone added this multi-arch problem. And this is exactly why I kept this space. Feel free to add more, but is that you, Joe, who added this multi-arch problem?
I didn't actually do that, but I assume that it was added after I mentioned it. I think it's a subcategory of the pods problem, but it's important, I think, to call out. In my mind, I think you can separate the pods problem into, there's a binary that we run right now that we probably shouldn't run, and then separately all the PSA and the scheduling and all that sort of thing that like, even if we own the binary, we still have to schedule a pod, right? So there's kind of the two separate problems that are related.
Right. Okay.
So one other thing that maybe is a non-goal is tenancy, right? So you talked about it before, right? So now we're promoting it to a cluster scoped API. But I also read the HackMD document. We're talking about, different kinds of users. And so I'm not sure, are we thinking of that there's still some kind of permissions model that we would kind of have a pseudo tenancy so you could have some visibility for privileged versus unprivileged clients? Or is that out of scope?
It is out of scope for this, but we are thinking about that, and someone feel free to correct me if I'm wrong. We are thinking about it in terms of the RBAC scoping problem. But at least for this iteration of our Chris, if you've noticed the milestones that we are talking about in our implementation towards the GA of OLM V1, for this milestone, we are keeping all of that out of scope, at least for implementing this CatalogSource. For now, we are just assuming that everything is cluster scoped and everything is going to be cluster scoped, and we are not thinking about the multi-tenancy problems right now. I don't know if anybody wants to come in.
The way I would describe it is that there's like the management of the operators that are installed on a given cluster, and that is not multi-tenant. So like at the cluster level, there's a set of operators that are installed, period, right? Like, and then there's another API that we're thinking about, but we haven't gotten quite as far on, which is, okay, so you've installed the operators. Now the cluster admin also gets to decide where those operators have RBAC. So it's sort of, I think we're sort of separating the problem a little bit from how OLM V0 thought about it. The operators are managed at the cluster level, and their RBAC is managed at the cluster level, but the operators themselves will have, there will be some knobs that cluster admins can use to control where those operators actually have permission.
Yeah, I guess what I'm thinking about is the permissions of the universe of what is provisionable, right? So, what catalog sources are visible, and I guess that still can be done through RBAC permissions, right? And layers that people can apply to these cluster scoped resources. It's just that we're not going to add to the illusion of namespaces as a way to do that scoping.
Yeah, so I think the answer is that there's a lot of design we can do here, but in general, I think the high level idea is that because we're doing cluster scoped resolution to make because at the end of the day, CRDs and APIs are cluster scoped. So because of that fact, we're going to do cluster scope resolution to make sure that across the entire cluster, you've got a consistent view and consistent, dependency tree resolution for everything that's been asked for.
Yeah, I think just for the audience who's maybe coming into this first time, I think having stampable cluster control planes is likely the future to doing that kind of thing, right? Technologies such as KCP or Hypercube, those or Hypershift, things like that, may offer other tenancy models. And so I think that is a key thing that people need to understand.
So that's a really good point. So OLM is sort of in the space of there's one control plane that OLM knows about. If you want multi-tenancy, like that's a different layer, and there may be integrations between OLM and that different layer, but in general, OLM is always going to operate with the idea that, at least OLM V1 is going to operate with the idea that everything is sort of scoped to a single control plane.
Yep, sounds good.
Okay. Cool. Then I think we can just move on to looking at some of the solutions that we've been talking about. So one of the solutions that we've talked about is having an aggregated API service, and that this is not something new, right? Like we've already talked about the package server.
Hey, real quick, I just wanted to get the pulse. Did anybody have any questions or any other problems that we didn't talk about that we should put on the list?
Yeah, I think the multi-arc one is a good one. That one's been hitting us recently, which is maybe why it's been promoted recently. And yeah, so I think there's a layer of multi-arc, right? What are the constraints that operators can run under versus what are the constraints that the actual catalog can run under? So I think that's probably what that's highlighting.
This one is, at least in my mind, this is purely about serving the catalog metadata. But I agree, there's the whole separate problem of like, okay, so your catalog metadata says that you've got some images that are used to run operators. Where can those images run? Like the bundle, the operator images and the related images. That I think for this conversation is separate.
Okay, so are we ready to move on to look at some of the solutions then?
Go for it.
Cool. Okay, so one of the solutions that we've looked at or we've discussed and prototyped is an aggregated API service. And I was just saying that it's not anything new. We've already had the package server API, but this solution talks about, and I've lost my cursor again. I don't know. Oh, sorry. Okay.
So real briefly, when you say aggregate API service, you're talking about, not a controller, basically not an operator controlling operators, right? So you're talking about an actual traditional, aggregate API, so just like the package server runs, right?
Right. It's a custom aggregated API service that sort of like, if you look at this diagram, it sort of sits behind the Cube API service, the API server. So yes, I'm talking, it's not a controller plus CRD, it's an aggregated API, it's custom API service.
So what are the advantages of doing that versus having a traditional, CRD controller pattern?
So yeah, okay. This gets into the why we thought about other solutions, but yeah, okay. So
the only reason I'm asking is because I think the package server is really confusing from a user's perspective, because you don't realize it looks at the surface level, it looks like it's a cluster API. But when you dive into it, it actually has namespace scope properties as well. So it has this weird hybrid thing. And so it gets really confusing. And so I don't want to reintroduce that confusion here.
I think the main advantage of having this a custom API server is, for example, if you look at the package manifest, right? And then if you're talking about getting rid of the pods, then you still need a way to, if you remember the API surface that we talked about from the gRPC API, that is still being used by clients, right? And what we've discovered over time is that even though we've exposed a lot of API endpoints, like get packages and get channel of packages, and the only API that really gets used is list bundle. So that means essentially there are two sort of information that's being used by clients on cluster. One is the package manifest and one is the bundle metadata, right? That is being used by the dependency resolver. So if we get rid of that pod that serves the gRPC API, we still need a way to expose that bundle metadata. And then that then becomes, besides the package manifest CR, and this, I call it the package manifest CR, but then I've realized last night that this is somewhat different from the package manifest CR, but I'll come to that later on. Besides this package data, we still need to expose this bundle metadata, right? And for example, this one becomes really easy for clients like Depi to sort of say list bundle, list all of the bundles that have olm.gvk value foo or bar. And so it's a very Kubernetes way of getting that bundle information instead of, connecting to gRPC pods. But if you look at this bundle CR that I've kind of written by hand, and it's not really a representation, like an actual representation of what a bundle may look like. This is like a huge CR. And then if you think about a single catalog having like 500 packages that have each package have 10 bundles in them at least, that becomes a lot of information that's being stored in the main etcd storage, and that just feels like an abuse of the main etcd storage. But instead, if you have a custom API server, then you can configure it to have a dedicated etcd storage, so then you can take that load away from the main etcd storage and still have this Kubernetes way of serving this information, but using a dedicated etcd storage that's away from the main etcd store. Does that inspire at least some confidence on, or clear up why this might end up being useful?
So, okay, I don't want to get into too many implementation questions and details yet, but I think I agree that the API, I think the important thing to talk about here is the APIs, probably not necessarily how where the data exists such that we can serve those APIs, although that'll be important at some point.
Right.
Yeah, just related to that though, I just wanted to say, I think people have gotten used to having CRDs to describe APIs, and people really value open V3 schemas, right? To be able to identify the API, what the APIs look like and how they're deterministic and so forth. By having things that aren't discoverable, I'm not saying that the aggregate API service doesn't do that. It's just you can't use CRDs, right? You have to use the actual kube control API resource and all that stuff to be able to find it. But I'm not super knowledgeable on that because I'm a CRD kid. But I just there might be some baggage there that you might not, that people might not be familiar with.
I think we're going to have a scaling problem with CRDs. Yeah, but just like Ben said, like if we've got, hundreds of packages that each have tens to hundreds of bundles, and the catalog changes, then all of a sudden we've got to go back and basically like scrape everything that we put into etcd or via the APIs or whatever, and make sure that all of that stuff gets rewritten back as the new updated stuff, right? And then not only that, but if it's a CRD, then there is the possibility that someone has write permission to those CRs. And so then we have to account for that possibility. And if someone changes a CR in some way that makes it differ from what the actual catalog source has, we've got to reconcile that back. So I think like I think it's probably a base tenet that we cannot have a package server API that allows cluster admins or anybody to write to it other than shipping a new catalog source.
Right. These are view only when it comes to any other client other than these two controllers writing these or creating these CRs. So at least for the CRD exploration also, that might be something to keep in mind, that these are just view only for any user. So the other thing that I think also ties into this is, for example, this package CR, when I was writing it out, I sort of like wrote that out in a way that says, okay, and I had a code block here, but it doesn't look like I included it. So it says that, okay, how can I, you can see it in the HackMD, how can I, if I have this package CR, it kind of opens up a lot of Kubernetes way of exploring content. Like I said, it's view only. So for example, today in the packet, Chris mentioned that, okay, this package manifest is which is a useful tool, but then it's not documented. And also it gives us the basic, okay, what are the packages in the cluster? And that's about it. But then we've had questions about like, okay, I want to see what channels are in the package. I want to see what the head of the channels are. And that's not there in the current package manifest CR. So this package CR, the way it's laid out, at least, is carries on from the FBC conversation where we were talking about, we had a lot of conversations about, okay, today, because of the way that operator authors bundle their operators, and that was sort of to fit into the SQLite database model, is all of this package level metadata is included in each of their bundles. But then with FBC, that's no longer needed. So we are hoping that at some point of time, we can have operator authors stop including all of that. Like, for example, the icon is included in each and every bundle metadata, and that's just a lot of information that's being duplicated throughout the FBC. And that conversation sort of carried out, or is an inspiration behind this package CR that says that, okay, for each package, there is a single icon, and there is a single list of channel entries that has the upgrade path in it. And all of that is exposed in the package CR over here. Oh, there you go. That's the code block that I was talking about. And that gives us the ability to kind of explore in a very Kubernetes way of what channels are there, or what are the head of the channels, etc. What is the upgrade path? And you don't need any extra tool to kind of do that. Sort of like you don't need to crack open the DB or look at the FBC and JSON and parse the FBC JSON yourself to look at the upgrade path or make sense of the upgrade path. We've also had conversations about including tooling to visualize the upgrade path and all of that stuff. I think having these entries over here makes that also easy. But the thing that I realized last night, so the other inspiration that I was trying to keep in mind was clients today have come to expect this package manifest CR in a certain way. So for example, the OpenShift client, OpenShift console, when you go into the UI console, it displays a lot of the information about all of the packages. You can drill down through different, pages, and you can see the CSV, or you can see the CRDs that the operator will install, and there's the description and all of that stuff. So the current package manifest is basically laid out in a way that the UI console can just take all of this information and use it in its pages instead of having to call this bundle all the time. But this information also, if you think about storing all of this in it's got the CRDs. That's should be there somewhere over here. It's got the CRDs laid out in the package manifest. Current CSV. Yeah, anyways, so all of this information being stored again and again in the main etcd database, I think that gets into a scaling problem. Right.
One other thing I got to add to that is that I don't necessarily think we need to worry about the way that clients currently consume package metadata, other than like clients need certain information from that data, right? But like, we don't have to build something that looks like package manifest because people are already using package manifest. This is sort of our opportunity to say, oh, there's a lot of things that we want to fix, and we're going to make a bunch of breaking changes at once. That's why we're calling this OLM V1. And so if we think there's something that is wrong with the package manifest API, and we want to really change stuff, like now's the time to do it.
Right. And I think up until last night, when I realized, when I was looking at these two side by side, I was resisting that out of the fear that that means for a lot of our clients, it's basically re-implementing a lot of the stuff to get to the same place that they are in today, which means it's a lot of work, and which is what V1 breaking change mean ultimately, which is fair, but it also means it's a hurdle in quick adoption of V1. But looking at these two side by side, I think what you just said, Joe, I think I'm more on board with that. Thinking about putting this package manifest as they are right now in the new CRs, I think that just goes against the goal of resource consumption, optimization of resource consumption. And if that means clients need to do that work, I think that I'm more on board with that right now. But yeah, so okay, so let me pause there for any questions, comments, suggestions, afterthoughts of just looking at this design. I know there's a bunch of talk in the chat. I haven't been able to look at those, but if anybody wants to highlight anything from there. Okay, so looking at the problems that we're trying to solve and whether this solution hits the mark, if you can, like, if you see this, like, yes, we solve the pods problem because there are no pods. It's an aggregated API service with a dedicated HCD storage, so it definitely solves the pod problem. You have the content available on cluster because Depi can just query this bundle CR and the console, or a user with kubectl only can query this to these CRs to find out information about the packages, and that also hits the the Kubernetes content exploration of cluster, so you don't have to curl HTTP pods and then process that response to find out information. Also cluster resource consumption, and that becomes possible because of this. We've got this dedicated HCD store or dedicated storage that is sort of away from the main HCD storage, and therefore it's not overloading any of the main cluster payload. But one of the problems I think that got highlighted when we were discussing this solution is the ease of maintenance. I think Chris already mentioned this sort of, like, everybody's used to this ubiquitous CRD, controller plus CRD, and that drills down to the maintainers of this project too, because we are so used to looking at controllers and CRDs. I think that's much more the comfort in even thinking about maintaining controller plus CRDs. And also, it was interesting, like I said, to bring back a conversation from earlier on about the package server manager, where we had this conversation about, okay, if one of the instances is down, we can bring up another instance. It sounds like, so the reason I had put this ease of maintenance is when I was talking to people, for example, I was talking to the API server team, and there was this conversation about, okay, you need to guarantee 100% uptime for this package server. But if one of the instances is down, for example, if the package server is down, that has the potential of affecting the main kube API or the availability of the main kube API server. And that sounds like a huge problem if that is in fact true. But I was trying to find issues upstream that sort of talks about this. There is sort of this problem that even if I say that there is not enough evidence for that, but then that also ties into the fact that there is probably not enough people using custom API services for there to be enough conversation or evidence around that. That
So one thing I was just going to interject here, Anik, is that if you look at this from a practical standpoint and just say like, okay, well, let's just go look at all of the OLM bugs that have ever been filed. How many of them are against the package server? There's like almost none.
right.
So I kind of think that like, yes, in theory, this is a problem, but in practice, like we haven't really had to do much of anything to make sure the package server is not causing major problems on the cluster.
Yes, but also I'd pad that conversation with, we did not have that many changes to the package server after it was implemented. The other components had multiple feature updates to them, which also increased the bug surface. But the package server, it was there for a sole purpose that kind of did it. It had a few bugs against it after it was implemented, and that's about it. There has been no changes to it at all since then. So that might also feed into that evidence of why we've not seen any problems. But yes, we have not seen any problems with the package server at all. And also I was looking, like I mentioned in the HackMD, we will not be the only one who will be implementing custom aggregated API service in the cluster itself. I think there are, for example, the metrics server, and there are a couple of other servers who do that, and they do that because the controller plus CRD is not enough for them. So for example, the metrics server that has a lot of specialized logic that it needs to perform that is not possible with the controller plus CRD. So there is precedence of using custom API servers. It's just it's not ubiquitous like controller plus CRDs. So it's still worth calling out in making sure that we guarantee that we can promise like 100% uptime, and also that it won't affect the Cube API server. But at least it's still worth mentioning that we need to take extra care in keeping that in mind. If we do decide that, okay, we will be using some form of a package, like a custom aggregated API service.
Yeah, I think two other things to consider. One, make sure that upstream customers are going to be comfortable installing this, right? So my customers, all of my products are all using, operators, and then, they're all on OpenShift, so downstream. So all of this is already there, it's already packaged, but upstream, they'll have to now install something on top of some other kube distribution, which now they have to install an aggregate API server, which could potentially affect things cluster-wide, which could be a little bit concerning, right? They might not want to do that. And then secondarily, now that we're actually going to be relying on other control plane tenancy models like KCP and so forth, we need to make sure this is going to work with that, right? So make sure that we can surface the APIs at different control plane levels and do bindings and things like that, because there's probably going to be first-class CRD approaches to do that, which won't be existing for API, aggregate servers, which are considered, I think, more advanced, right? So those are two things I'm thinking about. Adopters, cluster admins concerned about applying these things. How the heck do I make sure they don't tank my cluster? Because I can't quite see exactly what's in the box, like I could with other tools, and then make sure that I work with the future control plane tenancy models.
Yeah. So for that, I mean, these are really good points. The one point I'll make about this is make sure cluster upstream customers are comfortable installing that. Is today, if you install OLM, you're already installing the package server. Whether you know that or not, you're still installing
Yeah, no, I get that. So you've already got this today. Yep, totally got it. I don't know how it works. It's all magic to me, but yep, I get it.
Okay, and this make sure that it's compatible with Hypershift and KPC and all of this technology. I think that's a really good point too. If I don't know if you've had a chance to look at the prototype over here. If you look at and there's a demo over here. I will probably not sit through this demo right now for the interest of time. Then you can maybe I'm hoping that it kind of assuages some of those concerns that what's under the box. It's like if you look at this, it's sort of like not that far away from what the CRD controller plus CRD workflow is. So it won't exactly be a mysterious black box that does everything under the hood and nobody has access to. So as you can see over here, like you can look at the API server deployment and the dedicated HCD server deployment, the servers that is used to connect to this. So all of this workflow is still very familiar workflow from the controller plus CRD workflow.
Oh, that's fine. I just wanted to call it out as something to think about as we move forward.
Right.
Hey, so we've got like 15 minutes left. I wonder if what we should do now is pivot to like, okay, is there anything here that's a complete non-starter? And also like, what are the next steps in terms of what we want to do to start getting this sort of work into like the operator controller and DEPI? That seemed like a reasonable place to spend the last piece of this meeting.
Yeah, so you know what, let me just quickly go through because now it I think becomes very easy to sort of talk about the other two designs now that we have all this background. So let me just take 2 minutes to talk about that and then jump into what's the next step for this. So because of all of these problems around or concerns around the HCD that Chris also highlighted, we also explored this option of having an HTTP, like replace the gRPC server with HTTP servers. But we have a prototype that uses GraphQL HTTP servers. So sort of like in the pod itself, the FBC is being exposed by HTTP server, and that's it. So then clients can query instead of doing list bundle, or instead of us needing to implement the list bundle API and the get packages. It's just here's all of the FBC metadata exposed in the HTTP server, but with GraphQL, clients can query for build highly customized queries for just the relevant content that they need. And that means that now we are getting rid of the package server, custom API server altogether. But then that means that we need some sort of a plugin to enable that get packages channels in packages workflow. But that kind of leads us to, if you look at the comparison between the two architectures, that does not solve the pod problem, because we still have the pods. So everything that's associated with the pods will still be there. And then the content exploration on cluster will not be very kube native. So we will need the plugin. So anytime any users need to explore the content, we'll have to tell them, go install the kubectl operator plugin, and then you can explore.
I'm not seeing how the pods problem is different than it is with the aggregate API servers. In both cases, I mean, the aggregate API service is exposing one API from catalog content. The GraphQL approach is exposing a different API from catalog content. And in both cases, you've got to run a pod, either OLM runs a pod or users run a pod, but somehow a pod's got to run to expose that content, right?
Yeah, but the aggregated API service, these are not pods that we are creating and managing ourselves, right? This is the controllers. That's the only pod. And then this, so there are some pods. But
you could do the same thing with GraphQL. Right. You could manage those pods.
And regardless, there's like the catalog images exist in image registries. And right now, the only way we have of peeking inside those catalog images to extract the catalogs is to run a pod. So regardless of which solution we go with, you've got to run a pod just to be able to get to that catalog content.
Right. And you've still got the binary problem over here, right? Like you still got the multi-arch problems, and you still have a binary that's serving this content, whereas in the
Well,
aggregate,
not necessarily well, I guess in both concepts, like something has to understand what that catalog content is, right? Like I was saying earlier, like if we wanted to do GraphQL, we could have a pod that knows how to go and fetch the catalog image, find the FBC, copy it over into our own container that we define that's specific to the OLM version, and then run it, right? In the package, in the aggregate API service option, it's essentially the exact same thing, except the aggregate API service knows how to parse the FBC. So either way, it's a binary, but it's now a binary that OLM on cluster controls, not the catalog image.
right. So I think, and I'm kind of trying to keep the time in mind. Let me just try to quickly talk about this architecture. Like if you look at the problems or it sounds like there is a lot to discuss in that. How does this pod problem not get solved or not come to the picture when we are using the aggregator service? But in the interest of time, unfortunately, I was trying to stick to this point where I was trying to make the point where we said that, okay, since we are not hitting the mark over here, and let's just assume that's the case for now, instead of with the lack of conversation that we could not have because of time, we were thinking about how can we try and hit all the mark by walking back from the problems that we are not hitting and using the help of the ideas that we talked about, so the aggregated API server and the GraphQL, and this sort of architecture came into the picture, which is this is not an aggregated API server. It's a controller manager that owns the catalog source CRs. But then when you create a catalog source, this controller manager sort of pulls down the container image or the OCI artifact in its own hosted system, hosted file path, and exposes the content of that FBC from its own file system, mounted file system. So there is no pod for each of the individual.
There has to be unless we solve the problem of knowing about. So this is more of a downstream question, but it applies upstream as well because it's Cryo. Like Cryo supports ICSPs, image content source policies. There's a bunch of stuff that right now we get for free because we ask the container runtime to go pull the image for us. So I think what you're suggesting in this picture is we're not going to ask the container runtime to pull the image. We're going to go and pull it directly. But that also has some problems in that, like, okay, well, then it sort of breaks some of the disconnected mirroring sorts of features that we currently support.
So if for example, if you talk about if you're talking about like using Cry to pull down that image, you're talking about for example, a job, like how we do the bundle unpacking today, right? For bundle CRs. Yeah, so we can have jobs that go and pull down the image, but then the storage of that, once we have it in memory for this controller manager, can be stored in its file system, or even memory, and then exposed from that.
Yeah, that's true, but you still have a pod there.
Yeah, which is the job pod, which is still not as problematic as being managed by us. It does lead us to the problem of
that's kind of why Anik, I was trying to split out some of the pods problem, because there's really like 3 or 4 problems within that. So I think it's a little bit hard to figure out what we're talking about if you're not sort of thinking about each of the main sub pods problems.
Right. Okay. Yeah, so I mean it sounds like if, for example, users have a request, these unpacked pods, I want them, I want to schedule them, and I want the ability to schedule them in particular nodes, then that still has the gRPC pod config problems. and the PSA problem still shows up in the job pods. So yes, you're right. I think that does sound like there are problems that need to be kind of separated.
It could be though that, so part of the reason that cluster admins have cared where these pods are scheduled today is because they are long-lived, right? And so they actually serve stuff and they consume memory and CPU. If we say that these unpacked pods are now jobs and they just live for the duration that it takes to unpack them, then maybe that cluster admin concern disappears, because they're just temporary.
Right. That is a good point. We still need to, I don't remember if during PSA we had to care about the PSA enforcement of these jobs, but I'm sure we did, right? So we still need to care about that. We still need a way for users to be able to sort of configure these PSA level.
So I think there's kind of a twofold answer to that question. If OLM controls the binary and OLM controls this, and we do like a one-off unpack, you know, one-shot job rather than a long-lived pod, then we can essentially solve both of those problems. On the PSA side, we control the binary, so we can change the pod spec however we want, and still make sure that we can run our own thing, right? The whole reason that the PSA problem was a problem is because we didn't control that binary. That binary tries to do things that require baseline privileges. But if OLM controls the binary, then now we can update our binary and update our pod spec, and all the while the catalog content never has to change. Like, we're still good. There's a few caveats there, but in general, like, that problem is a lot simpler if we control the binary. And then the second part is, like, if we run a job rather than a long-lived pod, then the scheduling concerns about, like, what are the taints and tolerations? I think we can make an argument that that also goes away, because, you know, we'll run it probably in the scope of the OLM system namespace, and it'll probably run wherever the rest of the OLM system pods run, and they're short-lived, and, you know, that's the way it works. So that's, maybe that gets to the next steps that I had in mind, which were, what if we go and investigate a catalog, a cluster? So we have a cluster scope CatalogSource API. You still get to specify an image, but instead of us just running a pod with that image, we'll still run a pod, that it'll be an unpacked pod that ships something into either the, you know, something that cares about it, right? It could be DEPI, it could be a new package server, aggregate API server. But from the catalog source perspective, maybe we think of a way to make this more of a one-shot thing rather than a long-lived thing.
So do you mean that when a catalog source CR is created, the controller that owns the catalog source CR feeds the content, feeds the FBC essentially to all the clients that care about the FBC? Is that what you're talking about?
So maybe it's useful to talk about what RuckPack does for this problem, which is that it runs and this might not be the right solution, and Ben and I have talked about some ways to improve on this, but in RuckPack, the unpack pod finds the bundle information that it needs to unpack and then just writes it to the pod logs. And then anything that cares, so that pod then quits, but the logs are still there. Then anything that cares can go and read those pod logs to, you know, pull that into its own file system. There's concerns about, like, well, what if the pod logs go away? And we've got to think about that sort of thing. But in general, like, maybe there's a way that we can sort of extract that data somewhere such that other things can come along and pick it up. And now it's sitting there on the cluster on disk, but not taking up memory or CPU.
Yeah.
Or maybe you're right, like maybe we push it somewhere and do it that way. So we'll have to think about that, but I think maybe the the first place to start is with the idea that we have a one-shot temporary execution of something that extracts that catalog content. And then we can, there's a separate thing to figure out, okay, is that served then by a package server? Is it served by GraphQL? Like that's maybe the next step after this. But does anyone think that we should not at least investigate catalog images are content only, and we have something on cluster behind the catalog source, a new catalog source CR that extracts that content and makes it available to the next thing that needs to make it available to the server or to the cluster?
I mean, it makes sense to me, and I think it'd be really interesting to kind of dig down into some of the a little deeper into this, and that probably what you're suggesting, Joe, is go and explore this. It's just like for example, the first thing that comes to my mind is, okay, these jobs you talk about, that is unpack. Yes, that is probably going to be the main concern, right? Like the jobs are not guaranteed to be there once they are done. So then we do need a mechanism for the pod logs to be persistent in cluster some way or the other. And a sort of like a cube API that this aggregated API service exposes is that persistent storage essentially.
Yeah, well, so there's, I mean, essentially in this model, the content of that catalog is now on the cluster because Cryo has pulled that image. And then the only, like, if you want to get at it again, okay, run the job again. And Cryo is going to see like, oh, I've already downloaded it. All I need to do is start up that container and run it again. I'll re-unpack everything. Here you go. So in that world, the only actual network outside the network bandwidth used outside the cluster could be, hey, is the SHA for this tag still the same? And if the answer is yes, then I just start it all up again.
Interesting.
So I think like I think we can just take advantage of the fact that Cryo has pulled the image to say like, okay, that's kind of the source of truth for this. If the intermediate stuff that's used to unpack it disappears, then we'll just go and rerun that stuff such that we can get at it a little bit easier.
Okay. Okay. Yeah, that is an interesting, but then that still leads us to the, for example, in today's dependency resolver, like we've come to a place where we needed to cache the result because it didn't want to reach, or it was more expensive to reach out all of these pods. I want to say that at this point, we still, like, at least I'd have to still go and see how much of that network call was because of the list bundle gRPC call, or was it just reaching out of this is expensive no matter what. But there needed to be caches. So it seems like we might run into a place where Depi gets to a place where it says, okay, now I need to cache the pod logs in my process.
Yeah, and I mean, we could do some really interesting stuff here, right? Like in general, you don't expect the catalogs to change that much over time. Like every update is going to be a new bundle with a new channel entry or something. So I can totally imagine that like we could think about like, all right, well, what if we ran rsync? Like what if Depi stood up a pod that mounted, that did the unpack thing, and then it just runs rsync against that pod to update its cache. And then you're only getting the diffs of what changed from the last to this. So I think I think we can get pretty creative if we get to the point where the API is FBC rather than gRPC. You still have other problems and other complexities, like, okay, well then Depi has to go and process all of that FBC, and now that's a memory spike and a whole bunch of stuff like that, right? But maybe at some point then there's another solution for that piece of the problem.
Right. And I think that still talks about, for example, this part of the equation. Oops. This part of the equation where, you know, instead of having this gRPC, GraphQL HTTP server, we've got the pods. But then we still need to kind of like put that in this diagram and see how does that tie into this operator packages being exposed. And we already talked about this. How does DEPI process this? How does, for example, kubectl operator process this to get us this, you know, this nice little exploration of the packages. So that also needs to be exposed. So it seems like what we are talking about right now is having job unpack pods in this part of the architecture, but we'll still need to see how it ties into the entire overarching architecture.
Yeah, and I think the nice aspect of this approach is that, like, again, like we started this conversation out with, there's a whole bunch of problems and they exist in various pieces of the architecture. You know, let's focus on one of those problems and try to solve that without necessarily trying to focus on everything at once. And so, like, in my mind, you know, in my opinion, it seems like one of the biggest problems is this pod scheduling, PSA, binary, like all of those sort of things are, in my mind, probably the biggest problem. So if we can say, like, all right, let's go and build a solution that solves those problems and still leaves, you know, the rest of the architecture open for, you know, solving the other problems, then we've done something pretty useful. And then we can go and say, okay, we've got a CatalogSource CR, it's unpacked the stuff, it's updated its status to say, here's where you can go and find it. And now anything else that cares about catalog content can just look at that CatalogSource CR, wait for the status to say, here it's available somewhere, and then go and grab it.
Okay. Yeah, and okay. Yeah, I know you're trying to kind of focus on that particular problem, but my head is going to, okay, then if you need to create these packages, you know, to give us this kubectl or kube native way of exploration and stuff, then this controller itself can be responsible for creating this operator package CR from that pod log. So it doesn't need to, you know, look into its own memory or go reach out to pods and to create these operator packages. But yeah, it does lead us to how does DEPI process this? How does kubectl operator process this? But okay, I think,
yeah, I mean, to answer those questions, I think, like, well, okay, DEPI is going to know about catalog sources, or the package server is going to know about catalog sources. And then, like, when we get to the point that we want to consume what we've extracted, we need to answer those questions, right? But so the answer could be, all right, we'll run an intermediate pod that runs GraphQL, or it could be that DEPI looks directly at that content somehow and rsyncs it into DEPI's source cache, right? There's a bunch of different ways we could do it. It could be that DEPI talks to the aggregate API service directly, and now, like, DEPI doesn't even know that there's some FBC somewhere. So there's lots and lots of options, and I feel like trying to think about and solve them all at once is maybe making the problem too big.
okay. You know, it makes sense to me, and it is interesting. We are 5 minutes over. I don't know if anybody has any thoughts, comments, questions, suggestions. Okay, so it sounds like, at least from this meeting, we've got an overview of where we are. At least we've all caught up with where we are with this design, and it sounds like the next step would be, let's go and explore this, you know, help or pull these images with the help of Cry, and then have these unpacked pods that have the logs in there, and then take it from there. Okay, cool. We are at time. We are over time by 6 minutes right now. I'm going to give one last pause to see if anybody has any burning afterthought.
Anik, I just wanted to thank you for, preparing this Miro board and presenting all the information in a very consumable format so we could actually have meaningful discussion. This is a pretty big space that we're discussing, and the medium that you presented with today made it very easy to follow. So thank you.